Great. So I have the pleasure of going on just before lunch, so do bear with me. I'm going to talk about... Yeah, not my fault, not taking responsibility. So my name's Harry McClaren. I'm going to be talking about hunting hard, failing fast while maintaining integrity. Slightly different to what's in the program, but the content's quite similar. One second. There we go. So this is just my who am I. So I'm an alumnus of Napier University, so it's nice to be back. It's my third time speaking at this conference, so it's a real pleasure to be invited back, and hopefully I've got something interesting to share with you. I'm currently a managing consultant with ECS, based in their security practice, and what I kind of do day to day is I'm split between helping manage groups of security engineers, but I also head up a number of internal projects to kind of help innovate and support what we can do operationally. What we do is we run security operations centers, so we run them both on-site for our customers, but we also run an off-site managed service, pretty similar to the MSSP idea that you might have heard about, but we try and do a few things different. We leverage Splunk as a big data technology, and we do so in a way that we think differentiates us in the market, and we use them because we think they're the best at what they do. This isn't really going to be about any particular technology. It's not really about ECS, but worth pointing out. So this is what I'm going to cover. I'm going to try and get through it in a slightly shorter amount of time to give everyone a chance to have some lunch. But we're going to talk a little bit about what a SOC is made of, talk about what threat hunting is and why it needs to be very adaptive and agile, but how it can also impact the risk that SOCs face. We're then going to talk a little bit about how Splunk is very helpful in that sense, how we leverage DevSecOps for this problem, and what that ultimately does for hunters. So who in the room knows what a SOC is? Show of hands. Okay, so a SOC, Security Operations Center, is essentially a collection of functions that serve to detect and respond to threats for an organization. These are some of the capabilities that you would expect to find in a modern SOC. We've moved from this kind of initial, we monitor logs, we look for when threats have occurred, maybe we get alerts from our email gateway or antivirus, to much more detection-based, correlation searches, rules, more analysis, so that might be a bit more ad hoc, looking at how we can look across different types of data to try and infer things. Maybe that includes things like behavioral analytics or anomaly detection. Then, of course, there's a response function, because there's an argument to say that is it worth having any capability to detect if you don't have a capability to respond? So you know you're infected, but you can't fix it. You know you've been compromised, but you can do nothing about it. I don't think that's 100% true, but I think there's a lot of value in thinking like that. If you don't have the capability to respond to a threat, is there much worth, other than perhaps for a report to go to the board about knowing what's actually attacking you? So the two more modern things that should live in a SOC, and that do in some cases, are the idea of hunting. So threat hunting, this is looking for things that you don't know about. Because if you knew about something, well, you would create a rule or a protection mechanism to stop it occurring, or at least when it does occur, that you respond. Threat hunting is kind of taking the proactive step and going, I'm not just waiting for a ticket or an alert or an alarm to go. What I'm looking for is I'm scouring my environment, scouring all the different logs I've got, all the different silos, all the different tools to try and find things that are hiding. And then finally, we've got the idea of automation orchestration. It's been mentioned by the presenters, but it's essentially the ability to take actions either in an orchestrated fashion. So I, as a human, say, I now want you to block this port on my Palo Alto firewall, and scripts go off in the background or tools go off in the background, and they do it for me. You've then got automation, which is rather than needing a human to make that decision, you empower the tool sets and say, whenever I see things like this, go away and do all these things. An example of that might be doing a virus total search on a piece of malware. If your analysts are, 100 times a day uploading malware to virus total, waiting for the results, screenshotting it, putting it into their ticketing tool, automate it. You're wasting a phenomenal amount of time when they should be doing things like threat hunting. So the model for threat hunting follows this kind of diamond model. So it always starts with a hypothesis. I'm going to look at what data, what tools I've got, and I'm going to come up with a way of trying detecting threats. I'm then going to put it into action. So I'm going to go and test my theory. I'm going to go and find out oh, I wonder, when I see these types of behaviors, is that a threat? And I might go and have to do some research. I might have to correlate that data with intel from the web, with white papers, with maybe reports from my SACA or similar. But ultimately, it's to lead to detection. So you pivot as a threat hunter, you look at what's out there and you go, this is a new way to detect this. So, for example, one I heard about last year, which was great, was a way to detect ransomware. Someone in a SOC had a hypothesis that, well, why don't we place a file on every single person's home directory, and we have the logging tool monitor that specifically, and any change to that file, because that file's secret, it's hidden, the user doesn't know it's there, any change to that file, instant alert. So it's an early warning sign that ransomware often blanketly encrypts a lot of things, especially text documents, things that are valuable to a user. That was their early warning system. It was like a canary. The canary starts to choke, you know that there's gas, same type of thing. So that got deployed. Hypothesis, what tools and techniques could we use to find this? Put in a way of detecting it. Done. That threat hunt is over. We now have a detective mitigation in place. So I'm now going to move on to my next hypothesis. So what this leads to is what I've called adaptive threat hunting in this. So the thing is that threat actors, the people that are attempting to harm an organization, are ultimately going to change. They don't remain static. Again, in all the presentations today, we've seen this. We've seen that massive escalations, constant polymorphic type properties of malware where it's constantly evolving and changing. But they're also changing their tactics. So they'll try one way. They get blocked there. Well, that's fine. I'm going to go around this way. So your threat hunters need to be doing the same, constantly being out there, looking at research, looking at threat data and intelligence to try and keep up. That's not your traditional SOC analyst job. Your traditional SOC analyst job is very much like a security help desk. It's monitoring tickets. I get a ticket, I triage the ticket. It's either a true positive and I escalate it and it's now an incident. Some action needs to occur, the response, or it's a false positive and don't worry about that. It always fires. We don't know why, but it's fine. Don't worry about it. That's the traditional side. But the problem with that side is that you're only looking at what you know about. Now, if you can remove a lot of that kind of churn from your SOC and empower them instead to hunt, you're likely to get far better results as far as the protection of your organization, because you're no longer just depending upon the vendor that developed a use case in your SIEM product from 5 years ago, which is one of 8 rules that are still turned on. You're going, okay, well, that's great. Yeah, leave them turned on, but we know what actions happen, so we automate those actions for those known things. However, all these unknown things, we're going to keep looking for and trying to find. And if you actually wrap a bit of a process around that, and it's got to be light, because the whole point of threat hunting is, it can be a bit over there. Oh, what about this? I wonder. You've got to empower people, but you can still wrap a gentle process where they can still define the hypothesis, what tools and techniques they're going for, how they're going to refine it, and whether or not it was successful. Are your SOC analysts or your engineers, are they trained in the right way to do threat hunting efficiently? Do they have enough background information about endpoint security, network security, to be able to hunt in those realms to actually provide value? Now, all that's great, and what I've just said is I'm advocating for all this threat hunting, all this constant experimentation. It's great, reminds you a lot of like rapid application development, it's like, oh, I'm going to attack it from every angle. However, within kind of security operations centers and within commercial businesses, you've also got an idea of risk, and you want to reduce risk to your organization. The problem with constant innovation, if it's not checked, if there's no governance wrapped around it, is it can also lead to significant problems. An example of this, which I've seen in a SOC recently, they were tuning a rule, so they had an open change ticket, so they had the authority to go into production and change a rule, and they added an extra 0. So their threshold went from, they were trying to change it from 10 to 20, and they accidentally fat-thumbed and added a 0. It was 2 weeks until it was found out, and then the question was, we actually made the change. Oh, well, this guy approved the ticket, and this was supposedly the person who made the change. Asked them, oh, no, I actually didn't do it in the end, but we had an open change, so it was fine, because the systems aren't connected. Well, what was that rule beforehand? I'm not sure. Okay, well, where do you, they're in Word documents, but they're not really up to date. So, the great innovation, I'm going to tune this threshold, going to make it more valuable, going to cut down on the false positives, suddenly introduced risk. And that rule failed to fire at all for 2 weeks. Now, okay, that's a single rule in a single SOC. But if you're doing what I'm just advocated for and empowering your SOC to, constantly experiment and improve, well, how do you marry that up with the risk of doing so? And whether that is, thresholds, the changing of rules, people changing the schema of databases within kind of traditional log management tools, there's a lot of places where that risk can occur. So as it turns out, and this shouldn't be relatively new, but it somehow is, there's a lot of things you can do to fix that problem, which I don't think we're looking at enough as an industry. And that is kind of the implications of DevOps practices, of culture and tools and techniques to that process. Now, this diagram, although quite busy, so I'm sorry about that, comes from Gartner, and it really is a brilliant articulation of how DevOps can help with security problems and how the leveraging of it helps you de-risk that kind of rapid change that you want to achieve. If you are in a kind of a legacy large enterprise and you already have what's called a route to live, so you have your development environment, maybe a test environment, maybe pre-production environment or staging and production, you already know that you need to introduce change carefully, but unless you have integrations with tools that you might describe as DevOps tooling, that can take weeks, if not months. It's very manual, it's very ad hoc. You have an open change, you have a design, but then you have to go very slowly through each one. Now that doesn't sound like it's going to be very helpful for threat hunters. If I discover a new threat in my environment, I want to make changes to my tooling to automate, to mitigate, to respond in a much more agile way. I need that agility to protect my organization. Imagine the frustration for a threat hunter that has just spent a week on a hypothesis that they've proven the value of, to then be told, okay, raise a change, the next change board is in 2 weeks, we'll then have permission to put it into test. Once it's in test, we'll do a week of UAT and then it will be in production. You've suddenly got 3 to 4 weeks where that threat is potentially within your environment causing harm, and yet you already know how to stop it or at least detect it. So, as I mentioned earlier, so ECS within our security operations centers, we usually leverage Splunk for SIEM type activities. And I've spoken about this last year about how we leverage it as kind of a next-gen SIEM, although I hate that term. So it's quite agile by default, kind of out the box. There's a few things in it that make it really good for threat hunting. One is its SPL, so that's its search language, is brilliant. You can do it all through the user interface, and you can just ask different queries. Yeah, you've got your saved queries, your rules, your correlation searches, your reports, your dashboards, but you also have this Google-like interface to ask new questions. And the reason you can ask it new questions and in new ways is because it's schema on read, not on write. So what that means is that the raw data from wherever your logging endpoints have come from, whether that's syslog, SNMP traps, Windows event data, API calls pulling down from AWS, whatever, it stores those events as raw data. It stores them in indexes, and then when you run your search, the search apparatus looks at that raw data and then splits it out according to your specification. So that schema on read enables you to ask a question in however many ways you want to mix and match that data without going, it must be called this, it must live in this location. We've heard again from other speakers how important it is to have things like normalized field names. How am I meant to know the difference between a source IP when it's spelt right, source underscore IP, but what about SRP underscore IP, or one just says SIP? That's fine if you're doing that calculation at read. It doesn't matter how it was stored originally, because I've got the raw data and I just tell Splunk to pull it back. So that's really good for pivoting on different data sets. And the other thing that turns out when applying DevOps principles is it's really hard to do things like maintain configuration if that configuration is in something like a database. Because I then have to export that database, re-import it. I may not have the option to import just a single table or a row at a time. I may have to do the full thing. It becomes very complex. So when configuration files are just normal text files that I can edit with a text editor, I can manage those much more efficiently. I can push them out throughout my route to live, my dev, test, and prod, really programmatically. And then finally, with a fully enumerated API, that's an application kind of programming interface, it enables me to use Splunk the way I want to. If I want to use a script to call its API and run a search and pass me the results, I can do that. I can do that in whatever programming language I want. I can tell Splunk to go and leverage other APIs that either come out of the box via their app store type thing, or one that I wrote myself. And that, again, that empowers threat hunters because they can mold the tool to their need in that moment, as opposing to have to go to market and go through an RFP process to get a new tool. So what we did was we looked at some of these, I say traditional, they should now be traditional within software development, moving away from waterfall, version control. So we looked at, rather than the kind of traditional waterfall methodology, design and then test and all these things, we said, okay, well, how do we, rapidly improve the speed and the innovation of our teams? So this is more for our kind of engineering teams that are building rules and building use cases, but it also goes for our threat hunters who can now have very quick sprints and go, right, we think about these threats, let's have a quick sprint and think about how we're going to rapidly engineer it, how we're going to improve our detection and response capability. We now make everything is now in version control. So version control, a ECS system, is essentially like track changes in Word, for those of you that are unfamiliar with it. It enables me to know who has made a change, when, and if I want to revert back to it. So I now have a complete history of a change to a rule, a dashboard, the way a system is configured. So when suddenly my system falls apart, because as it turns out somebody updated the wrong certificates, I can revert it and I can see it happen in the console. I can wrap control around that. And for example, what we do is, so we've got our development branch, and a branch is essentially a tag that says, this is stuff that's not ready for production yet. When they want to merge that, or essentially copy it into test and production, they have to get a peer review before they can take it to test. It doesn't need to go to a massive change board. It doesn't need to go through full kind of ITIL, documentation, but it's built into the system. It's a ticket. Another developer, another engineer, can you check that? It shows a like-for-like difference in the code. That's what I've changed. This is why. Cool, merged. We're now in test. And then with a little bit more control, so now you need the owner of the system to approve the merge. Same for going to production. Click a button, merge. Then you've got configuration management, and this is the tool that takes that code that's been merged or now copied into production, ready to be deployed, and it does it for you. So what we did with my internal engineering team that were working on this is I took away their access to production. So even though this was technically, like a dev production, I took away their access and said, anything you want to do in production, you do it through Ansible. You write a playbook for it. And that playbook, funnily enough, is in version control. So I can look back and see what they've been working on and what they're changing. So from a project perspective, that's really useful, but more when this goes into operation, how much more useful is it then? Where I can ensure that changes that are occurring in production as a system owner that potentially is the heart and soul of the security monitoring and response of a large bank, for example, I can have a lot of faith then in what's being changed and why. So, and then finally, then you get this full route to live. So we now have within this environment, we have almost identical code running through production down to development. When we make a change in development, they of course become out of sync, but that's fine because we're only promoting up. We promote that through to test, we run our automated integration testing, our user acceptance testing, and then it gets promoted into production. So we can now do that, and what we would class as kind of like a minor change to an alert, a dashboard, that goes from dev to production in 20 minutes. And that's identical code, and that's with full change control, with approval, the whole works. Now, of course, if someone's not at their desk to do the merge or approve, there's a gap, but that's a kind of ticking timer as opposed to the system. The system promotes rapid, safe change. And that is the big difference. And that's where we start to get that with what I said earlier about threat hunting and this agile ability to pivot and change, meeting up with the underlying systems and technology, facilitating it in a safe way. And so what we end up with is significantly empowered security operations centers or analyst engineers who are encouraged to fail because they fail safe. They can mess around in production. sorry, not production, they can mess around in dev to their heart's content, no problem. But they know that what they're messing around on is like production, because we're taking a feed of production data, we anonymize the key production elements, and we put it in dev. So they have like-for-like data, the same code running, the same underlying system configuration, because we're using containers, and it's awesome. So suddenly, rather than, oh, I can only do this in production because that's where the data is, or I can only do this in production because, oh, well, we know that test is nothing like production in reality. That's not how syslog's configured in test, so I need to test this in production. Test this in production, oh, that suddenly makes me a bit nervous as a system owner. Why are you testing it in production? It should be tested in test. Ah, but can't test it in test. Oh, okay. You know, it's a challenge, and it's one that I know many customers struggle with. So this kind of SIEM at the heart, your big data tool at the heart of this, because you do want a single view, you don't want siloed data, but you want to do so in a way that promotes this constant, how can we detect things more, how can we then automate them, but all of these things should be version controlled, transparent, and able to be pushed through a route to live so that you can be very, very comfortable as a system owner that no one's going to break anything. And so with the nature of everyone getting to lunch, that's the end. These resources don't work because you can't click on them right now, but they will later. So all my slides will get uploaded, and I've been Harry McClaren, and if you want to reach out, this is my contact details, and take questions at lunch because I'm hungry. Okay, thank you very much.